In this video, we make an introduction to Unit 14, devoted to the magnetic field. We will begin in this unit to show this introduction in point 1, and then in the rest of videos you will be able to analyze what is the force exerted by a magnetic field and what this how this impacts the motion of charges when they are moving in a magnetic field. And last of all, we will see two applications of this motion of charges in magnetic fields, which are the velocity selector and the spectrometer of mass. So to begin this unit, I'm going to make this introduction into the magnetic field, just telling you that the magnetism was already, at least it was already known by the Greeks, who realized that there was a stone called magnetite that had properties, strange properties, magnetic properties. And from the name of this stone, magnetite, we have the derivation of magnetism or magnetic. I think you already know that magnets have always two poles. So we distinguish between the South Pole and the North Pole. And if you confront two poles that have the same polarity, they repel. And if the poles that you confront have a different polarity, they attract to each other. However, it's very important to realize that the poles always come in pairs. So you cannot manage to get a single pole without the other one. So if you get a magnet and you try breaking it in two, you will again have for these two magnets there will be again two poles, a North Pole and a South Pole. The Earth is actually a natural magnet. It's the magnetic field in the Earth is believed to be generated by the currents of molten iron in the Earth's outer core. We can think of it in a first approximation as a big bar of a magnet, where the South Pole and the North Pole of this magnet align approximately with the rotation axis of the Earth. It's not completely aligned, but mostly. And the South Pole of the magnet is located in the geographic north, and the North Pole of the magnet is located in the geographic south. So you can then use needles to align, and they can be used as compasses. And the use of magnets to navigate goes back to at least the 12th century. The basic magnetic interaction is between two charges in relative motion. So it's another example of action at distance force. So that's why we're going to use the concept of field as we did in the electric field, and this time it's going to be the magnetic field. So we're going to think that the magnetic field is going to act on charges that are moving, and it's going to exert a force which we will call Lorentz force. And in this unit we explore this. We explore the force exerted on a moving charge or on a current, an electric current, due to the presence of a magnetic field. In Unit 15, in the next unit, we will explore what the sources of this magnetic field are, and we will see that the basic source is really a moving charge. So we will see then in Unit 15 that the moving charges or currents are creating the magnetic field. In Unit 16, which completes the electromagnetism part of the general physics subject, in Unit 16 we will see that the changing magnetic fields are able to induce electric currents. With this introduction finishes this video, and for the rest of the unit you are invited to look at the following videos.